Welcome to Part 4 of the Android Interview Series 2024, focusing on Kotlin coroutines. In this episode, we'll explore the core concepts, practical usage, and interview questions around coroutines in Android development. Coroutines are a powerful tool for handling asynchronous tasks efficiently, making your code more readable and responsive. Whether you're preparing for an interview or aiming to deepen your understanding, this guide will walk you through everything from basic coroutine principles to advanced patterns. Let's start by understanding what coroutines are and why they matter in modern Android apps. Coroutines are cooperating functions that provide a more efficient and readable way to handle asynchronous tasks. Unlike traditional threads, coroutines are not bound to any particular thread. They can suspend execution in one thread and resume in another, enabling concurrent operations without blocking resources. Introduced in Kotlin version 1.3, coroutines have become a staple for modern Android development, allowing developers to write code that runs concurrently with minimal overhead. This flexibility is key to building responsive apps that handle background tasks smoothly. Coroutines differ from traditional threading in several ways. They are lightweight, allowing many coroutines to run on a single thread due to their support for suspension. Suspension lets you pause a coroutine and resume it later, saving memory and supporting numerous concurrent operations. Coroutines also follow structured concurrency, tying their lifetime to a specific scope, which helps avoid memory leaks. On Android, coroutines offer main safety, ensuring long-running tasks don't block the main thread. Built-in cancellation support simplifies resource management, and cooperative multitasking lets coroutines yield control back to the scheduler. Structured concurrency is a design principle where the lifetime of coroutines is tied to a specific scope. This ensures all launched coroutines within that scope complete before the scope itself finishes. Coroutines form a hierarchical structure, with parent coroutines managing their children. Automatic cancellation prevents incomplete tasks, and scope-aware exception handling propagates errors to the parent, ensuring operations fail fast if any part fails. Structured concurrency simplifies resource management and avoids leaks, making it a best practice in Android development. Suspend functions are special functions in Kotlin that can be paused and resumed later. When a suspend function executes, it releases the thread, allowing other coroutines to use it. The syntax is similar to regular functions, but includes the suspend keyword. Suspend functions can only be called from a coroutine or another suspend function. This feature enables efficient asynchronous programming, as tasks like network calls or database operations can be suspended without blocking the thread, improving app responsiveness. CoroutineScope defines the lifecycle of a coroutine, controlling a group of coroutines in their context. Each scope includes a dispatcher and configuration settings, which coroutines inherit. In Android, scopes are often tied to components like ViewModel or activity, ensuring coroutines are canceled when the component is destroyed. This prevents memory leaks and unnecessary background work. Grouping related coroutines under a single scope allows for consistent error handling and efficient task management. Kotlin provides three primary coroutine scopes for Android development: GlobalScope, CoroutineScope, and Android-specific scopes like viewModelScope and lifecycleScope. GlobalScope lives for the duration of the app and is not tied to any lifecycle, making it risky for most use cases. CoroutineScope allows custom lifecycle and context management, ideal for repositories or service classes. Android-specific scopes tie coroutine lifecycles to components, automatically canceling coroutines when the component's lifecycle ends, reducing manual cleanup and preventing leaks. Coroutine builders are functions used to create new coroutines, simplifying concurrent task management. Each builder serves a different purpose. The most common builders are launch, async, run blocking, and with context. Launch is used for fire and forget tasks, async for parallel tasks that return results, run blocking for blocking the current thread until completion, and with context for switching coroutine context within a coroutine. Understanding these builders helps structure concurrent operations effectively. Launch builder is the most common way to start a new coroutine. It launches a coroutine concurrently without blocking the current thread. Launch is ideal for tasks where you don't need a return value, such as updating UI or performing background operations. It creates a job representing the coroutine, which can be managed or canceled as needed. Launch is frequently used in ViewModels to bridge non-suspending code with suspending functions, enabling seamless integration. Async builder launches a new coroutine and returns a non-blocking future that promises a result later. Async is used for parallel execution of tasks when you need to retrieve and combine results. You can call await on the deferred to get the result once the coroutine completes. This builder is perfect for scenarios where multiple tasks run concurrently and their results need to be processed together, such as fetching data from network and database simultaneously. The run blocking builder runs a new coroutine and blocks the current thread until completion. It's mainly used in unit tests or main functions where suspending functions need to be called without a coroutine context. In Android development, run blocking should be used sparingly, as it can block the main thread and cause UI freezes. This builder is useful for testing coroutine behavior or initializing data synchronously during app startup. With context is a suspending function used to switch coroutine context within a coroutine. It suspends the current coroutine, switches to the specified context, and resumes execution in the new context. With context is synchronous and returns the result directly, making it useful for switching between threads seamlessly. This builder is often used to move execution from background threads to the main thread, especially when updating UI after fetching data. Coroutine context is a set of elements that define the behavior and characteristics of a coroutine. It includes dispatchers, jobs, exception handlers, and coroutine names. The context determines how and where the coroutine will be executed, allowing developers to specify threading, error handling, and custom attributes. Managing coroutine context is crucial for ensuring tasks run on the appropriate threads and handle exceptions consistently. Coroutine dispatcher determines the thread or threads on which a coroutine executes. Kotlin provides several standard dispatchers, main for UI thread dispatchers, I/O for I/O operations dispatchers, default for compute-intensive tasks and dispatchers, unconfined for starting in the current thread. Choosing the right dispatcher ensures tasks are performed efficiently and safely, especially when updating UI or performing background operation. A job represents the lifecycle of a coroutine, controlling its status, active, completed, or canceled. Jobs are hierarchical. Canceling a parent job cancels all child jobs. Each coroutine returns a job instance, allowing explicit lifecycle management. Adding a job to coroutine context helps prevent memory leaks and ensures tasks are canceled when no longer needed, especially in Android apps tied to component lifecycles. Supervisor job is an implementation of job that acts as a supervisor for child coroutines. It allows child coroutines to fail independently without canceling the entire scope. This is useful when multiple tasks run in parallel, and you want each to continue even if one fails. Supervisor job is ideal for scenarios where independent error handling is required, such as loading multiple resources simultaneously. Coroutine context can hold elements like coroutine name, used for debugging or custom needs. Assigning a name to a coroutine, such as coroutine name, coroutine, makes it easier to track in logs and debug issues. This feature is particularly helpful in complex applications where multiple coroutines run concurrently, allowing developers to identify and manage them efficiently. Cancellation in coroutines is a cooperative mechanism. Coroutines can be canceled by checking for cancellation at specific points, such as using asActive or calling cancel on their job or CoroutineScope. Cancellation propagates through the hierarchy, ensuring a clean state across related tasks. Common cancellation points include suspending functions like delay, yield, and with timeout, which automatically check if the coroutine is still active. When a coroutine is canceled, it throws a cancellation exception. This exception signals that the coroutine was canceled and is not considered a failure. Developers can catch cancellation exception explicitly to handle cleanup or logging. Using finally blocks ensures resources are released and additional cleanup is performed, maintaining app stability and preventing resource leaks. Proper error handling in coroutines prevents crashes and ensures failures are managed gracefully. Use try-catch blocks within coroutines to handle exceptions as in synchronous code. Coroutine exception handler catches uncaught exceptions at the scope level, working with root coroutines launched using launch. Exceptions in async coroutines are deferred until await is called. Supervisor scope and supervisor job allow independent error handling for child coroutines, ensuring one failure doesn't affect others. Timeouts in Kotlin coroutines are managed using with timeout and with timeout or null functions. With timeout sets a maximum time limit for coroutine execution, throwing timeout cancellation exception if exceeded. With timeout or null returns null instead of throwing an exception, simplifying timeout handling. These functions ensure resources aren't tied up by long-running tasks, maintaining app performance and responsiveness. Parallelism in coroutines is achieved using the async builder. Launching multiple async coroutines allows tasks to run concurrently, and await retrieves their results when needed. This approach is ideal for scenarios where multiple operations, such as network and database calls, need to be performed simultaneously and their results combined efficiently. Coroutine channels are a communication mechanism that allows coroutines to send and receive data asynchronously. Channels provide safe communication without traditional concurrency primitives like locks. They are useful for coordinating tasks, streaming data, or implementing producer-consumer patterns, making concurrent programming more manageable and efficient. A mutex, short for mutual exclusion, is a synchronization primitive used to prevent multiple threads or coroutines from accessing shared resources simultaneously. Mutex provides a non-blocking way to synchronize access, allowing only one coroutine to access critical sections at a time. This prevents race conditions and ensures data consistency in concurrent operation. The yield function in Kotlin coroutines is a suspending function that allows a coroutine to suspend voluntarily, giving other coroutines or tasks a chance to run. When yield is called, the dispatcher can switch to another coroutine, then resume the original one when its turn comes again. Yield helps improve cooperative multitasking and resource sharing among coroutines. Multiple coroutine results can be combined using functions like awaitall or awaitall or null. These functions take multiple deferred objects and return a list of their results or null if any fail. This approach is useful for aggregating results from parallel tasks, such as fetching data from multiple sources and processing them together. The Produce Coroutine Builder creates a producer coroutine that generates a stream of values and sends them through a channel. This builder is ideal for implementing producer-consumer patterns, where a producer sends data items to one or more consumer coroutines. Produce simplifies streaming and coordination of data between coroutines. Coroutine Start. Lazy is a coroutine start option that delays the start of a coroutine until it's explicitly needed. When launched with Coroutine Start, Lazy, the coroutine won't run immediately. It starts when start, join, or await is called, or when its result is accessed elsewhere in the program. This option is useful for optimizing resource usage and controlling when tasks begin. A debounce mechanism for user input can be implemented using coroutines. By launching a coroutine that delays execution for a specified debounce time, you can cancel the previous coroutine if new input arrives before the delay completes. This ensures only the final input is processed, reducing unnecessary operations and improving performance in scenarios like search or form validation. Coroutines are widely used in Android app development for managing background tasks, network requests, and UI updates. By leveraging CoroutineScopes tied to Android components, developers ensure tasks are canceled appropriately, preventing memory leaks and improving app stability. Coroutines simplify asynchronous programming, making code more readable and maintainable. Preparing for Android interviews requires a solid understanding of coroutines, their scopes, builders, and error handling mechanisms. Interviewers often ask about structured concurrency, cancellation, and parallelism. Practice writing coroutine code, handling exceptions, and managing resources to demonstrate your expertise. Familiarity with coroutine patterns and best practices will set you apart in technical interviews. Developers often encounter pitfalls when using coroutines, such as improper scope management, forgetting to cancel coroutines, or mishandling exceptions. Structured concurrency and proper error handling are essential to avoid memory leaks and inconsistent states. Always tie coroutines to component lifecycles and use supervisor job for independent error handling. Reviewing common mistakes helps build robust and reliable apps. The producer-consumer pattern is commonly implemented with coroutines and channels. Producer coroutines generate data and send it through channels, while consumer coroutines receive and process the data. This pattern is efficient for streaming, coordinating tasks, and managing workloads in concurrent applications. Channels ensure safe communication and synchronization between coroutines. Several patterns emerge in coroutine usage, such as fire and forget with launch, parallelism with async, and context switching with context. Choosing the right pattern depends on the task requirements and desired behavior. Understanding these patterns helps structure code effectively, improving maintainability and performance in Android apps. Channels enable streaming data between coroutines, supporting producer-consumer and other communication patterns. Streams can be processed asynchronously, allowing real-time updates and efficient data handling. Channels are essential for coordinating tasks and managing workloads in concurrent applications, making them a valuable tool in Kotlin coroutines. While this episode focuses on coroutines, it's important to note that Kotlin flows are another powerful tool for handling streams of data asynchronously. Flows build on coroutines, providing operators for transforming, filtering, and combining data. They are ideal for reactive programming and managing data streams in Android apps. Jetpack Compose, Android's modern UI toolkit, integrates seamlessly with coroutines. Coroutines manage background tasks, fetch data, and update UI components in Compose. Using CoroutineScopes tied to Compose components ensures tasks are canceled appropriately, maintaining UI responsiveness and preventing leaks. Coroutines play a crucial role in Android architecture and framework. They support clean separation of concerns, efficient background processing, and responsive UI updates. By tying coroutine scopes to architectural components like ViewModel and repository, developers ensure robust lifecycle management and error handling. Follow best practices when using coroutines. Always tie coroutines to component lifecycles, use structured concurrency, handle errors gracefully, and avoid blocking the main thread. Choose appropriate dispatchers for tasks, and use supervisor job for independent error handling. These practices ensure stable, efficient, and maintainable Android apps. Debugging coroutines involves assigning names, tracking jobs, and monitoring coroutine scopes. Use coroutine name for easy identification, and log coroutine states to detect issues. Proper debugging helps resolve concurrency problems, memory leaks, and performance bottlenecks, ensuring smooth app operation. Effective resource management is vital in coroutine-based apps. Always release resources in finally blocks, handle cancellation exceptions, and tie coroutines to appropriate scopes. This prevents leaks, ensures clean state, and maintains app performance, especially in long-running or background tasks. Controlling concurrency in coroutines involves using mutex, channels, and structured concurrency. Mutex prevents race conditions, channels enable safe communication, and structured concurrency ties coroutine lifecycles to scopes. These tools help manage concurrent tasks efficiently, ensuring data consistency and app stability. Kotlin coroutines are essential for modern Android development, offering efficient asynchronous programming, structured concurrency, and robust error handling. Mastering coroutine scopes, builders, and patterns prepares you for interviews and real-world projects. Always follow best practices, manage resources, and debug effectively to build stable and responsive apps. Deepen your understanding, explore Kotlin flows, Jetpack Compose integration, and advanced coroutine patterns. Practice writing coroutine code, managing scopes, and handling errors in real projects. Stay updated with the latest Android development trends and resources from experts to enhance your skills and career prospects. Thank you for joining this comprehensive guide to Kotlin coroutines for Android interviews. We hope you found these concepts, patterns, and best practices useful. Continue learning, practicing, and applying coroutines in your projects to build efficient, responsive, and robust Android applications. Happy coding and best of luck in your interviews.